All right, here's the last sort of indeterminate form where we've got to take a natural log, and this time it's the indeterminate form of the limit as x approaches uh, infinity of x to the 1 over x power. Well, this time what you're going to have is if the top never changes and the bottom does, you're going to have this whole infinity to the 0 power situation. Okay? Just think about it. If x continues to grow towards infinity, it's going to be infinity. If 1 over x grows to infinity, it goes to 0. Well, almost anything to the 0 power is 1, but in this case, with infinity, that's not a specific number. So we've got to do a little bit more investigating to find out what to do. Let's go ahead and take the natural log of the function. So we're looking at the limit as x approaches infinity of the natural log of x to the 1 over x power. Okay? So again, just pausing on this for a minute and working with just strictly the natural log of 1 over x, you have x times the natural log of x, which gives us the natural log of x over x. And what's nice about this is we have a fraction set up so we can start using L'Hopital's rule. Remember, if we check infinity on this, we're going to get, this time if we check infinity, the limit as x goes to infinity of the natural log of x over x, what happens is on the top, the natural log continues to grow. Now, it might not look like it on your calculator, but if you punch natural log of x in and you look, it's going to grow towards infinity. On the bottom, x that goes to infinity goes to infinity. So we're left with this guy, which means that we have to take the derivative of the top and bottom, use L'Hopital's rule. And when we do that, the derivative of the natural log then becomes 1 over x. So we like that. Hey, that's pretty easy. And the derivative of x is just 1. So when we do all of this, what we're going to find is when we look at the limit as x approaches infinity of 1 over x, we get 0. So back up here to all of this business. Okay, what do? Well, to finish this problem off, you look at the limit as x approaches infinity of e to the natural log of f of x, which we just discovered is going to be 0. So this is e to the 0 power, which is 1. So on this, you just might notice that all these problems got a little bit easier as we went, partially because we became more familiar, and especially on this last one, there was only one time we had to use L'Hopital's rule, and we didn't have to use some weird trick to get there. So there you go. That's a lot of information I've given you from this section over your L'Hopital's rule. There's a ton of different examples. It takes a lot of practice with this to work all these things out. So just be patient. See what you can do on your own. Try them out on your own and see if you can't match some of the answers that I got.